Hello everyone. Here's your lesson for section 3.3, Proving Lines Parallel. Missy McCarthy, Okemos High School math instructor. In this particular lesson there's only one objective, and that's to use angles formed by transversal to prove that two lines are parallel. If you recall from the last section we were using the fact that the lines are parallel to prove something about angle pairs. So what we're doing in this section is just the complete converse of what we were doing in the last section. So remember what a converse is? It's not the shoe that we're talking about. We're talking about if you have a conditional statement, if P then Q, the converse of that statement is if Q then P. So we're going to take all of those postulates and theorems that we learned in the previous section, and we're going to do the converse of those and show that those are also true. The basis for this is starting with the converse of the corresponding angles postulate. So here you can see the converse. It says if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So it says the complete converse of what we learned yesterday with the corresponding angles postulate. So the thing that you're given is that the angles are congruent, and the thing that you know as a result is that the lines are parallel. Whereas yesterday, the thing that we knew was that the lines are parallel, and then we could say that the angles were congruent. So we can use the converse of the corresponding angles postulate in a very similar way to what we use the corresponding angles postulate for. So it says use the converse and the given information to show that L is parallel to M. So if I look at my first set of given information, it's angle 4 is congruent to angle 8. So I'm going to identify those, and I have identified those as corresponding angles. And so because angle 4 is congruent to angle 8, we can say by the corresponding, the converse of the corresponding angles postulate, we can conclude that L is parallel to M. Okay, for the second one here it says measure of angle 3 and the measure of angle 7. So I want to identify those. So I'm going to just change my color here. Angle 3 is here and angle 7 is here. So I also identify those as corresponding angles. But they give us something here, and they give us the value of x. So angle 3 is actually 4 times 30, which is 120 minus 80, which is 40. And angle 7 is 3 times 30, which is 90 minus 50, which is 40 degrees. So that means the measure of angle 3 is equal to the measure of angle 7, which means that angle 3 is congruent to angle 7. And then we can say that L then is parallel to M by the converse of the corresponding angles postulate. Okay. All right, another postulate in this section is called the parallel postulate. And it simply says that through a point P, not on line L, there is exactly one line parallel to L. So if we look at what this means, it's pretty much saying that if you have a line L, this is my line L, and you have a point P that's not on line L. This postulate says that there is only one line. That doesn't look very parallel, but there is only one line that passes through P, so that this line, let's call our new line M, is parallel to L. You can't draw more than one line through P. And again, this is a postulate, so it can be proven. It's one of those statements that's accepted as true. So it says the converse of the corresponding angles postulate is used to construct parallel lines. The parallel line postulate guarantees that any line L, you can construct a parallel line through a point that's not on L. So this is the guarantee, and we'll use the construction of congruent corresponding angles in class tomorrow to show that we can only draw one line. So just as you might have suspected, yesterday we had the alternate interior angles theorem, the alternate exterior angles theorem, and the same side interior angles theorem. So to go along with those, we have the converses of all three. We're going to prove this one right now on the next slide, and then we'll prove these two in class. Okay. But again, they all start with something about the angles, and then they draw a conclusion about the lines being parallel. Here, angles are congruent implies lines are parallel. Here, angles are congruent implies lines are parallel. And here, angles are supplementary implies lines are parallel. Okay, so let's prove the converse of the corresponding angles postulate. So I'm going to start with my T-proof setup, and I have my statements and reasons. Okay, so the very first thing that I'm given is that angle 1 is congruent to angle 2. And I'm going to come up with an argument of my own before I start putting into this format. So I'm thinking to use the transitive property. If angle 1 is congruent to angle 2, those are alternate exterior angles. But angle 1 is congruent to angle 3 because they are vertical angles. And so then I'm going to use the transitive property to show that angle 2 is congruent to angle 3. And then by the corresponding angles postulate, if these corresponding angles are congruent, that means the lines are parallel. So that's my argument. So I got angle 1 is congruent to angle 2. That's given. So I'm going to say angle 2 is congruent. Oh, nope. I want to start with angle 1. Sorry. Angle 3 is congruent to angle 1. I know that by the vertical angles theorem. Which says that vertical angles are congruent. So if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 1, if I read this the other way, angle 3 is congruent to angle 1 and angle 1 is congruent to angle 2, then I can say that means that angle 3 is congruent to angle 2 by the transitive property of congruence. And then if 2 and 3 are congruent, then that means the lines are parallel. Line L is parallel to line M because 2 and 3 are corresponding angles, and so this would be by the converse of the corresponding angles postulate. And there you have it. Okay, so let's try this example. We've got the diagram here, the given information and the theorems that you learned to show that R is parallel to S. That's what we're going to use. So if we know that 4 is congruent to 8, we know that 4 is congruent to 8. Those are alternate exterior angles. So by the converse of the alternate exterior angles theorem, which we just proved, I believe, we can say that line R is parallel to S. Here, again, we've got to plug in the 5. We know something about two other angles here. We know something about angle 2, and we know something about angle 3, which are same side interior angles. So if I plug in 5, I get 58 here for angle 2. If I plug in 5, I get 125 minus 3, which is 122 here. And I know that 122 plus 58 equals 180. So it looks like because my same side interior angles are supplementary, the lines are parallel. So by the converse of same side interior angles, we can conclude that R is parallel to S. Okay, another proof. Here we're going to prove that two lines are parallel because that's what this whole section is about, but by being given some particular information to start that isn't necessarily the same as one of the theorems or postulates that we've learned. So I'm going to set my T-proof up. Statements and reasons, or two-column proof, I'm sorry. Sometimes called a T-proof. And I'm going to reason through my argument before I get started. I know that P is parallel to R, so I'm going to put that information on the diagram, that P is parallel to R, because we know certain things because the lines are parallel. So we know that also angle 1 is congruent to angle 3. Okay, so I'm thinking I'm going to say P is parallel to R, angle 1 is congruent to angle 3. Angle 2 is also congruent to angle 3 by the exterior angles theorem, and if we have 1 congruent to 3 and 2 congruent to 3, we can use the transitive property to say that that 1 is congruent to 2, and then the alternate, the converse, to say that line L is parallel to M. So if you didn't follow that, I'm going to do it right now. Okay, so the very first thing I'm going to say is that P is parallel to R, and that's given. Okay. Because P is parallel to R, I can say that that means angle 2 is congruent to angle 3, and that's by the alternate exterior angles theorem. Okay, so then next they give me the fact that angle 1 is congruent to angle 3. That's given. I'm going to use the symmetric property here to say that means that angle 3 is congruent to angle 1 only because I wanted to follow the transitive property, symmetric property of congruence. And then because 2 is congruent to 3 and 3 is congruent to 1, I can say angle 2 is congruent to angle 1. And that's by the transitive property of congruence. Okay, so if we've got 1 and 2 congruent, then that means that line L is parallel to line M by the converse of the corresponding angles postulate. That's that. Okay, so rewatch any parts of the video that you need to. If you're watching on YouTube, feel free to type questions and comments or in the comments section. And there's a lesson quiz on the next slide. I will see you guys tomorrow.